Alright, so still working with current, we're now going to examine circuits, different kinds of circuits. So the lab today should look like this: Sparky the Electrician. Purpose: to study various arrangements of a battery and bulbs and the effects of those arrangements on bulb brightness. Alright, first part, using only a battery, a bulb, and a piece of wire, we want to light the bulb. Now, the one tip I usually give is that the current has to go through the bulb, not just to the bulb. It has to go through that little tiny filament so that the resistance in the filament causes it to glow. Now, given that, the most common mistake is to hook the bulb up like this, and then it doesn't light. And then over time, the wire gets warm, and you'll have to take my word for it that it got uncomfortably warm. That's because we have a short circuit. So the current flows through the wire, path of least resistance, and not into the bulb. Okay, so if you look at how the bulb is built, there's a conductor here, and then an insulator in between. So giving that tip, the second most common mistake is to do things in light of that and then just alter it by now the wire is in contact with the side and the bottom, and then when we hook it up to the battery, nothing lights, and over time the wire once again gets warm. Okay, so again the current has to go through the bulb. So if you look at the bulb once again, it has to go in one conductor, through the filament, and out through the other conductor. And then if you think about how a flashlight is built, the bulb sits literally right on top of the battery. So then how do I get the current from, it's now going into the base through the filament, how do I get it out? Well, if you remember, the bulb screws into the flashlight, so if I let this piece of wire act as that, and then boom, now we get lighting. Okay, so go ahead and draw this configuration. If you can see through my stubby hands. Another possible configuration would be to turn it on its side and then complete the circuit. Tell me where to put the, there we go. So now it's going in through the threads and out through the base. Okay, so that's two configurations. There should be two more. Okay, what if we flip the battery? Oh, what a good idea. So it doesn't matter which way the current flows in a simple resistor like a light bulb. If we do the same arrangement but with the flow in the opposite direction, and then like this, this is going to be funny. I don't have enough dexterity. Yay! So there's 4 arrangements of part A. Whoop. Pause. Alright, I forgot. In part A, you're also supposed to examine a receptacle. And if you look at the receptacle, there's threads on the side that the threads in the light bulb interact with. And then there's a metal piece on the base separated by an insulator. So this part of the bulb interacts with that piece of the base, and then the threads interact with the threads here. And then one wire is hooked to the base, the other wire is hooked to the threads, and so you plug in the bulb or screw in the bulb. How many teachers does it take to light a light bulb, and hopefully just one. Ah! Okay, freaked out a second, but there we go. The bulb is lit. On to part B. So part B, we're just going to be messing around with different arrangements, and it says to, with one battery, light as many bulbs as you can. So if you'll zoom in, not too far, we can see that I can light one bulb. And if I unhook this, hook another to it in a row, I can light two. If you get real close, you can see they're barely lit. And what about three? And they don't light. But does that mean there's no current going through them? If only there was something we could use to measure if current is flowing through or not. Pause. So I have the same three bulbs that did not light, and if you look closely at the magnet, or the compass, when I connect the circuit, deflection occurs. Even though it's not enough current to light the bulbs, there is current still flowing through it. Pause. Now there is another way we can light the light bulbs. If I put them connected directly to the both light bulbs light, and then I connect again directly to the power source, I'm getting three light bulbs. So at what point do you think I should go? Can I add another one? Yes. Can I add another one? Yes. Can I get up to like 10 or 20? Yes. But since there's no senior boys here, we won't do that. We'll stop now, we'll save the juice in the battery, and we'll go on. Now, here's two bulbs, or two batteries. Whoops, three bulbs, that one's burned out. Scratch that, it didn't burn out, it just came unhooked. So notice the three bulbs are all lit. They're lit more brightly because now there's twice as much voltage. And again, I could go from 3 to 4, 4 to 5, 5 to 6. I can do an unlimited number, but all we would do is drain the voltage from the batteries. So let's try them in a row and see how we do. Pause. The next part says using two batteries. Still on that part, but we're going to try them in a row. So there was one bulb. What if I try two? They both light, but they're not as bright. What if I try three? And this is, again, they're in what's called a series, end to end. Will they light? What do you think? Ooh, they do, but they're really dim. What about a fourth? Ooh, they do, but they're really dim. And what about a fifth? The fifth wouldn't light, but we could check it with the compass and we would get deflection. So let's move on to the next part.